One way of shaping traffic is with what's called a leaky bucket traffic shaper, where each flow has its own bucket. In a leaky bucket traffic shaper, data arrives in a bucket of size beta and drains from the bucket at rate rho. The parameter rho controls the average rate. Data can arrive faster or slower into the bucket, but it cannot drain at a rate faster than rho. Therefore, the maximum average rate that traffic can be sent is this smooth rate rho. The size of the bucket controls the maximum burst size that a sender can send for a particular flow. So even though the average rate cannot exceed rho, at times the sender might be able to send at a faster rate as long as the total size of the burst does not exceed the size of the bucket or does not overflow the bucket. The leaky bucket allows flows to periodically burst, and the regulator at the bottom of the leaky bucket ensures that the average rate does not exceed the drain rate of the bucket. For example, for an audio application, one might consider setting the size of the bucket to be 16 kilobytes, so packets of 1 kilobyte would then be able to accumulate a burst of up to 16 packets in the bucket. The regulator's rate of 8 packets per second, however, would ensure that the audio rate would be smoothed to an average rate not to exceed 8 kilobytes per second or 64 kbps. Setting a larger bucket size can accommodate a larger burst rate. Setting a larger value of rho can accommodate or enable a faster packet rate. The leaky bucket traffic shaper was developed in 1986, and soon to follow was a technique called RT traffic shaping.